So this is how I model for my students a radioactive substance. This is 200 dice in this box, 200 dice you can see in the box. And so to me, each die represents an atom of a radioactive material. Now, when we roll the die, it lands on a number completely at random, okay, like those two land on 5. Or when I roll these, then they land on different things. Now, so the way the game is played is that you roll all the dice every turn. And if a die lands on 1, then that represents an atom that decays, which means it comes out of the box and never goes back in. So we take the shoebox, we make sure there's no holes in the shoebox the dice could fall out of. We grab the shoebox by both ends, we grab it by both ends, shake it like that. So all the dice have been rolled. Then I carefully turn the lid over, shake it around so that all the dice, no die is on top of another die. I just shake it until all the dice are none or on top of the other. And then I'm just going to eliminate every single die that landed on 1. We're just going to take out every die that landed on 1. So I'm explaining to my students, and they need to be counting this, so that we always have a running total of how many dice are left. So I explain to my students, well, just like these dice land on 1 at random, radioactive atom decays completely at random. I cannot tell you when this atom or that atom will decay. I can only tell you the probability that the atom will decay in the next second, in the next hour, in the next million years, between 1 million and 2 million years. What's the probability that the atom will decay at that time? So so each of these turns of the game is like 1 second or 1 day or whatever you want to think of it as, 1 unit of time. So the students need to be counting how many dice they pull out, because they have to be able to record how many dice are left remaining in the game. So the game starts slow, but then once all the dice are accounted for, so now we know how many dice are in the bucket, so how many dice are left in here. They're going to record that after 1 turn, how many dice are left. Now notice, once a die is eliminated from the game, that die will never go back into the box ever again. Okay, so now I got all these dice. I'm going to shape it. Okay, this is second turn. Turn number 2. Oh, we have some dice on top of the others, so we're just going to shake until all the dice, no die is on top of another die. Then we're going to pick out more dice. And we're just going to keep a running total of how many dice are left. Once a die goes into the box or when it goes in the jar, it never ever comes out. And then we're going to see that the amount of dice left does not decrease as a line, but rather as an exponential curve. And that is just like the remaining atoms of a radioactive substance decreases as an exponential curve. So let's have a look at some data for that and how we can analyze it.